Hello Algebra 2 students. This is a Regent review on transformations. In this video we'll cover both transformations and even and odd functions. The graph below represents national and New York State average gas prices. It gives a key. New York State is the dotted line and it's modeled by g of x, so I would label that g of x. And c is greater than 0, which expression best approximates the national average, the stars. So we have to pretty much see which transformations are occurring here. It looks like it's going down, right? So it's going down by c. If it's going down, that would be g of x minus c. Which transformation would this be? This would be to the left c units. This would be up c units. This would shift right c units. And then this is shifting down c units. These are all translations. Okay. Which transformation occurs from the first graph to the second? It looks like it's flipping, right? It's flipping over the x-axis. So if it flips over the x-axis, you're negating y, right? So let's look what we have. Option 1, that would be shifting down 2 units. Didn't do that. Option 2, shifts right 2 units. Option 3 negates your entire y value, your entire output. So that would reflect over the x-axis. Your answer would be option 3. In option 4, it negates just x. So then that's reflecting over your y-axis. That would look like this, right? And we said the transformation that occurred was a reflection over the x-axis. And that would be option 3. Okay, even and odd functions. Just a quick overview. If it's even, when you plug in a negative, so if I plug in negative x, it should give you the same output as it would if you had that same value as positive, that same input positive. An odd function, if you plug in a negative x, then that will give you negative f of x. If it's neither, then it's neither even or odd. Even functions reflect over the y-axis. Odd functions have a rotational symmetry over the origin, about the origin. If f of x is even, which function must also be even? Okay. So imagine this. F of x is even, right? So let's come up with a classic example of an even function. We have, let's say, x squared. If I shifted that right 2, would that still have symmetry, or would that still have symmetry over the y-axis? No. So it's definitely not 1. What about, so I'm going to move that back. What about if I move it up 3? is that going to affect its symmetry over the y-axis? No. So that would still be even. In 3, that would be moving left 1, so it would no longer have symmetry over the y-axis. And then for 4, that would be shifting left 1 and then up 3. The up 3 doesn't change it, but the left 1 does. So it would only be that. Okay. Which function is even? So let's go through it. We said if it's even, you plug in a negative, it will be the same output as if it wasn't negative. So for sine, I'll use an angle that I know, right? So on the unit circle, we have 30, 45, 60. Sine is your y values. So remember 3, 2, 1, 1, 2, 3. Let's use 60 degrees. So we know that sine of 60 degrees is radical 3 over 2. Now we have to check sine of negative 60. You could put that in your calculator as long as you're in degree mode here, right? I mean, it really doesn't matter what angle you put in. You could put in any input. So sine of, let's stick with 60 in this case, but I could have put sine of 5 and then sine of negative 5. You're just checking that you get the same output. So I am not, oh no, I'm in degree mode. I'm good. I end up getting whoops. I end up getting negative 0.866025438. Let me check what that is. Radical 3 over 2. Radical 3 over 2 is that same number, but it's positive. So is that even? No, it's not the same number. So sine is odd. By the way, quick trig review. Let's say you wanted to find that it was negative radical 3 over 2. What you would do, you would use the reference angle. So negative 60 plus 360. First you want to find the coterminal angle. You'd get 300 degrees. 300 degrees is in quadrant 4. The reference angle with that, right? This is the 300 degrees. The reference angle would be 360 minus 300, which is just 30 degrees. That's not true. 60 degrees. So then you would do sine of 60. Sine of 60, because you could use your reference angle. We already said it was radical 3 over 2. Last step, all students take calculus. Only cosine would be positive here, so it's negative. And you get negative radical 3 over 2. So that's what you would do if you didn't want to use your calculator. But obviously it's very easy if you use your calculator. And you don't have to use the perfect angle. Use 5. Just make sure you're using 5 and negative 5. And you'll see. So this is odd. Now let's check x squared minus 4. Let's plug in a random value, f of, let's say, 3. So 3 squared minus 4. Let's plug in negative 3. Negative 3 squared minus 4. I'll put it in parentheses just so. 3 squared minus 4 is 5. Negative 3 squared minus 4 is 5. 5 equals 5, so f of 3 equals f of negative 3. That is even. right? This, just a quick discussion for these. This is the absolute value function. The absolute value function could be even. Oh, I moved a little too fast. The absolute value function could be even, but it moves to the right too, so that affects its symmetry across the y-axis. It's no longer symmetrical across the y-axis. It also goes up 5, but that doesn't affect it. The same thing as the quartic function. Your quartic function could have symmetry across the y-axis. In this case, it probably shifts. It's just you don't see the shift because it's not factored out. So what you could do to prove that it's either even, odd, or neither, you would just do exactly what we did here. You'd plug in positive and a negative of the same number. Okay. And then lastly, it says algebraically determine whether this function is odd, even, or neither. So let's check. You know, if you really didn't want, you could plug in, absolutely. You could plug in, let's say, -3 and +3, right? But let's pretend that just randomly worked out because it was like a point of intersection or something. Then that's true, and then you could try other points, and then it's even more likely that it's, not a coincidence. Or something else that you could do, so I'll show you just one other different way. Plug in -x. -x to the 4th, if you have a even power, you know that negative is going to become positive. So that's x to the 4th. Think about it. -x times -x, positive x squared. Times -x, -x to the 3rd. Times -x, positive x to the 4th. Same thing here. It's an even power, so you know it's going to be positive x squared. Is this the same as this? It is. So we just algebraically determined that for all -x, it's going to be the same as j of x, as for all x. So we could say, since j of x equals j of -x, the function is even, right? This is the last problem, so let's just kind of go a little bit deeper into it. What if you would have gotten j of x, j of -x, equals -x to the 4th plus 3x squared plus 4? That's the same as saying negative j of x, right? It's all times negative. So then that would have been odd. But that just wasn't the case. And if it was neither, then it would be neither. It wouldn't just be the negative value of that number or the same as that number. Okay. Hope this helped. Thank you.